Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon to all of you. Thank you for coming to the class today. So we will continue our dynamics class. We are still in the first chapter, and before we continue with the topic that I would like to discuss with you today, I would like to do some a little bit of summary of what we have learned so far in dynamics class. So this is week number 4. So basically we have been having dynamics lecture for about a month now, 4 weeks. So if you remember, the first topic that we cover in the first chapter of this course is called Kinematics of Particle. Okay, I have explained that kinematics means we are talking about the displacement, the position, s, and the change of position is displacement. We also calculated the velocity v, and also we calculated the acceleration a. So this is what we cover in kinematics. Okay, and the first topic that we have discussed is the rectilinear motion. If you remember, rectilinear motion. Okay, rectilinear motion means that the motion of the particle is in straight line. Okay, there are under rectilinear motion we have discussed two subtopic. Okay, under rectilinear motion there is continuous, three subtopics. There is continuous motion. Okay, this is the standard motion lah that we have discussed. The velocity v is equal to ds over dt, and the acceleration a is equal to dv over dt. And then we have the case where the acceleration is constant. So we discuss constant acceleration. Okay, in constant acceleration you can we have derived three equations that you can use when it comes to constant acceleration. And then finally, for rectilinear motion, we discuss about erratic motion. Okay, where the motion is not continuous, but there is different time interval. So for example, from t equals to 0 until 5 seconds, the particle moves with a certain parameter. In the next 10 seconds, for example, the particle move with different characteristics. So that is what is defined, or what we have discussed in erratic motion. Okay, so ini yang kita dah belajar dalam rectilinear motion. This the first subtopic of kinematics of particle. And then in the second subtopic, we learn about curvilinear motion. Curvilinear motion. Okay, under curvilinear motion, there are another three subtopic. Okay, the first one, curvilinear motion basically deals with different coordinate system yang kita boleh guna, that we can use to solve the problem related to curvilinear motion. So the first coordinate system is the rectangular component. Rectangular. Okay, rectangular component is the normal xy coordinate lah, xy axis. And then you have the tangential, normal and tangential. Normal and tangential. Okay, this one is n and t, nt coordinate. And then the last one that we have just discussed in the previous class is the cylindrical coordinate system, where you have the radial axis as well as the transverse axis theta. So These are what we have covered so far. So basically we have learned approximately 6 subtopics. Okay, kita dah belajar 6 topik kecil di bawah chapter Kinematics of Particles. So today we are going into the second last subtopic. So basically we have 2 more subtopics and then we will be finished with the first chapter. If you remember from my in the first class, I have explained that we have 4 chapters for dynamics. So by next week we will be finished with the first chapter. So there will be 3 more chapters to cover. So for today's lesson, we are going to discuss about absolute dependent motion. So it is called dependent motion. Okay, and then it is also related to number 4, which is very it is almost similar, has some similarity. Number 4, which will be covered next week, that is the relative motion. So these two will be the last topic that we will discuss in the first chapter of dynamics. Okay, so today we are going into the dependent motion analysis. Do you have any question so far on what we have learned in dynamics? Ada apa-apa nak tanya? So basically saya dah explain yang kita telah pun cover 6 subtopik lah. Dalam rectilinear motion ada 3 subtopik yang kita telah cover. Dalam curvilinear motion pun ada 3 subtopik. If you don't have any question, I will continue with topic number 3, which we are going to discuss today. That is the dependent motion. Ada apa-apa soalan? Okay, kalau tak ada soalan, I hope everything is clear on the overview of the first chapter ni yang kita akan tamat dalam minggu depan lah. Okay, do you can you hear me clearly, my voice? Boleh Okay, so let's go to what we would like to cover today. So today's lesson is called the absolute dependent motion analysis of 2 particles. Okay, apa maksud dia nanti kita terangkan. Let's look at the outcomes of today's lesson. So at the end of this class, you should be able to formulate the relationship, hubungan di antara position dan chord length. Apa maksud dia nanti kita bagi tahu chord length ni apa. And then you should be able to derive the velocity and acceleration equations of dependent motion. And finally, we will try to solve problems related to dependent motion of 2 particles. Okay. Dependent motion ni apa? Dependent motion ialah in many problems, kinematics problem, the motion of one object depends on another motion of another object. For example, if we have, let's say, one mass yang color biru ini, it is a box or whatever object it is, and then there is a pulling force yang color hijau ni pulling the object, pulling the cord. Cord ni tali ya, cord ataupun rope ataupun string. So samalah, if you find these terms in the book, in the question ke, so you need to understand kalau ditulis cord ataupun string ataupun rope ke apa, it means this cord here lah, dia tali ni yang menyambungkan di antara objek ini dengan another object. In this case, the other object is the hand of someone pulling the cord downwards. Okay, so in this case, apa ni, the pulling force yang color hijau ini is pulling down, which will cause the object color biru to move up. Okay, so now the objective of this chapter is to find out what is the velocity, what is the acceleration of these 2 items dekat sini. Okay, alright. let's look at a simple example of dependent motion analysis. So ini this is another example. So there is an object A, which is by looking at the figure, looking at the picture here, you can see that A is smaller than B. So apa ni? By visual, we will know that point A will move up lah. Point A will move up because point B will be travelling down. Point B akan turun ke bawah because it has larger mass than point A due to the size lah. If we assume it that way, B is the mass of B is larger than A, so it means that when we release these two objects, point B ataupun object B will travel down and object A will travel up. So there will be two velocities. VB akan ke bawah, VA akan ke atas. Okay, so now what we want to know is how can we calculate the velocity of A as well as the velocity of B. So ini yang kita akan belajar dalam this subtopic dependent motion analysis. So the question is how to find the velocity and acceleration of A and B. Okay, mula-mula kita cari velocity and then afterwards we will find also the acceleration. Okay, there are a few steps that you need to know on how to solve this, which I will show to you step by step. Okay, step number 1 is to establish an origin at a fixed point. Okay, by looking at this figure, dekat mana yang you rasa origin yang kita boleh pakai? Origin ni mesti pada fixed point. So kita akan kena cari satu point yang fix, yang tidak berubah, dan kita kena set dia sebagai origin. Which point do you think is the best to set as origin? Point mana yang tak berubah? This black dot, right? This black dot here is not moving. Okay, so we can set this, if you can see. Okay, we can set this black dot here, the center of the pulley. Benda ni kita panggil pulley, so dia ada tali wrap around the pulley. So tali tu akan menggerakkan kita punya objek. So we can set the center of the pulley as the origin, O. So kita panggil origin kita sebagai O. So that will be the first step. Okay, once we have established the origin at the fixed point, kita namakan dia O, we will establish a datum. A datum ni apa? Datum ni ialah satu reference line. Reference line ni mesti passing through the origin tadi. So in this case, we will establish a reference line, ataupun normally dalam buku semua dia panggil sebagai datum. We will establish a datum passing through point O. Okay, so dia mostly datum ni akan jadi horizontal lah. Dia bukan vertical, tapi bergantung kepada jenis pergerakan ini. Okay, dalam case ni because the object will be moving up and down, so datum ni akan kita buat pada horizontal datum, horizontal reference line. Okay, that is step number 2. Step number 3 is to set up coordinate system. Okay, kita dalam case ini kita tak pakai XY coordinate because the motion is only in one axis. Okay, so most of the questions related to dependent motion dia akan jadi hanya dalam satu axis. Dalam case ni motion dia hanyalah pada axis yang vertical axis lah. So point A is going up, point B is going down. So kita pilih coordinate system berdasarkan motion objek tersebut. So in this case motion B ini pointing down, so we will define the coordinate system positif ke bawah. Okay, so we use the origin tadi O to define the coordinate system kita. S kita panggil dia sebagai S, bukan X atau Y. Normally kita akan gunakan simbol S for the coordinate system of this type of problem lah, dependent motion ini. Dan dia mengikut motion object tersebut. So currently object B is moving down, so kita define S ini ke bawah. Boleh juga nak define S ke atas positif mengikut motion A, dan jawapan nanti pun akan dapat jawapan yang sama sahajalah. Okay, so in this case, in my example, I define the coordinate system pointing down ke bawah. Okay, step number 4, define the position of every object with respect to origin. Okay, dalam gambar ini ada berapa objek? Ada berapa objek? Tolong jawab. Siapa-siapa? Berapa objek ada dalam gambar ini? 3 objek termasuk puli kan? Okey, tapi puli ni kita tidak kita bukan something yang kita nak tahu berapa speed dia. So berapa velocity dia ataupun acceleration. So dalam problem ini we only focus on A and B. So there are 2 objects in this problem lah, in this figure. So what I mean by number 4 is the position. Tadi kita dah kata ini origin kita pada O. O is the origin. Coordinate system kita pointing ke bawah. So we need to know what is the position of A, what is the position of B. Dia macam coordinate lah. Kalau kita ada XY coordinate, kita pilih satu point dalam XY coordinate dan kita akan dapat coordinate dia, let's say X is equal to 2, Y is equal to 4, so 2,4. Itu kalau kita ada 2 axis. Now we only have 1 axis, so we need to find what is the position of A and B. So position of A daripada datum. So this is why we draw the datum. Datum ni berada exactly at the origin lah. So we draw a position vector pointing ke bawah sehingga ke point A lah. Sehingga ke A ni, tak perlu sampai ke center bawah ni, hanya sepanjang chord ini sahaja, sepanjang tali ini sahaja. This will be SA kita panggil. SA is the position of point A. Same goes for B. Kita akan buat juga position untuk B. So we have position B sampai ke sini, position A sampai ke sini, SA and SB. So by looking at the figure ini, kita tahu SB is longer than SA lah. Okay, that is step number 4. Step number 5 is to identify. Kita sekarang ni melihat kepada cord, tali. Tali ini yang berwarna hitam. Tali yang berwarna hitam ini yang menghubungkan kedua-dua objek A and B. So the black cord is the one connecting the two objects A and B. So kita nak kena identify throughout the motion A akan naik, B akan turun, which length of the cord ini yang remain constant, dia tidak berubah throughout the motion, dia tidak berubah. Do you think SA ini berubah dalam bila A bergerak ke atas? Adakah SA itu kekal dengan panjang tersebut ataupun dia menjadi semakin pendek? Which one do you think? SA, the length of the cord SA, dia akan jadi makin pendek ataupun kekal dengan panjang yang sama? Makin pendek. Betul. So SA akan jadi makin pendek apabila dia naik atas. SB pula dia akan jadi makin panjang. So SA and SB bukan constant. So di mana constant length ni? Dekat mana you rasa constant length of the rope, of the tali, of the cord tadi? The constant length ialah di sini, di atas ini. Kalau saya boleh zoom in sikit, nampak tak? Tali tadi yang berwarna hitam daripada A straight wrap around the pulley sehingga ke B, sehingga ke bawah ini B. Dan pada sepanjang masa tali yang berada di atas pulley ini, dia kekal dengan panjang yang sama, dia tidak berubah. You boleh imagine tak throughout the motion? Can you imagine? Boleh?
Yes.
Okay, good. So, this is the constant length. SA akan berubah with time. So, dia as the time goes, SA akan jadi semakin pendek. Same goes for SB. As the time increase, SB will become longer. That is the position. But this length of the rope of the cord around the pulley, around the top pulley here is constant. Length dia constant. So that is step number 5, which is to identify the constant length dalam kita punya figure ini. Okay. Alright. Next, number 6 is to find the relationship between the variables. Sekarang ni kita ambil total length of the cord, panjang keseluruhan tali. Panjang keseluruhan tali ni kita andaikan sebagai LT. Okay, LT ialah panjang keseluruhan tali. So, can you tell me how do you calculate LT based on all these variables yang kita ada? Anyone can tell me? LT is equal to apa? Ada? Good. SA plus SB plus C. LT ialah, LT ni panjang keseluruhan tali, panjang ke semua tali ni. So, LT will be SA, panjang daripada sini ke sini, plus panjang the constant length C plus panjang SB. So, LT will be equal to SA plus SB plus C. This will be the total length of the cord. Okay? Boleh faham tak ni? Ada siapa-siapa yang keliru? Any of you is confused about this? I can explain again. Ataupun semua faham? Boleh semua? Okay. Alright, good. So now, daripada ni kita ada altogether ada empat component. There are 4 components. Kita ada LT, total length of the tali, of the cord, SA, SB, and the constant length C. So, panjang tali ni dia berubah tak mengikut masa? Maksudnya dia kekal tak panjang yang sama atau dia berubah? Anyone? Dia berubah ke dia kekal? Saya tak dengar tadi. You jawab apa tadi?
Kekal.
Kekal, betul. Throughout the motion, A naik ke atas, B turun ke bawah dan sebagainya, panjang tali tetap sama. So, LT is constant. Tadi pun kita dah bagi tahu this part here, bahagian di atas ini pun constant. SA dan SB tadi kita dah bagi tahu juga dia vary with time. So maksudnya as the time increase, for example, SA will become shorter, SB will become longer. So these two components are the variables. Okay, are the variables. Dia berubah mengikut masa. Okay, so LT is constant, C is constant, SA and SB is variable, vary with time. Okay, now to find the velocity, we will differentiate the position over time. Betul tak? Remember kita dah belajar awal dulu, V is equal to ds over dt. Betul lah? V is equal to ds over dt. So we will do d over dt of all of this. Okay? D over dt of LT, d over dt of SA, d over dt of SB, and d over dt of C. Tadi kita dah define semua benda, apa LT, apa C, SA dan SB. LT is the total length. Okay. What do you think d over dt of LT ni akan jadi? Anyone? Differentiate the total length of the cord over time. You akan dapat apa? Okay, tadi kita bagi tahu panjang tali itu tidak berubah. Sepanjang masa panjang tali tu tidak berubah. T sama dengan 0, T sama dengan 1, T sama dengan 2, T sama dengan 5 saat. Panjang tali kekal. So, kalau kita differentiate panjang tali yang kekal tu over time, apa kita akan dapat? Dia berubah tak over time? Betul, Ahmad Daniel, thank you. Bila kita differentiate something yang constant over time, dia akan dapat nothing, dia dapat 0. So for LT, differentiate LT over time, dapat 0 because LT is constant. Differentiate C ni over time, dapat 0 juga sebab C ialah constant length dekat sini, so kita dapat 0. Kedua-dua ini kita dapat 0. Apa pula d over dt of SA dan d over dt of SB ni? Bila kita differentiate, kita dapat apa? Ini saya dah bagi tahu tadi. Awal dulu kita dah bagi tahu bahawa ds over dt sama dengan velocity. Pandai. Amar Ashraf, thank you. ds over dt is equal to velocity. Jadi, bila kita differentiate d over dt SA dan d over dt SB, apa kita dapat ialah VA dan VB. Okay, VA dan VB. Okay, so tadi D over DT LT kosong, D over DT C kosong. So this is the relationship yang kita dapat. This is what I mean by find velocity differentiate over time. Step nombor 7 ialah to do some differentiation. Okay, dan kita susun semula. So kita akan dapat VB sama dengan negative VA. Alright, so inilah relationship velocity yang kita dapat untuk case ini. So maksud dia kalau VB ini turun ke bawah dengan 10 meter per second, VA akan naik ke atas dengan velocity yang sama. Okay, velocity yang sama. So if VB is going down 10 meter per second, VA is going up 10 meter per second. Kenapa VA negatif? Sebab direction dia lain. If you recall, kita tadi awal tadi kita dah tunjuk di sini, okay, VB turun bawah, VA naik atas. Jadi kita dah define kita punya coordinate system tadi ke bawah positif. So that's why VB is positive. VA dia arah bertentangan dengan coordinate system kita. Dia pergi ke atas. So that's why dia negatif. Alright? Okay. Ada apa-apa soalan setakat ini? Setakat velocity.
So, boleh kita assume the direction ke atas? For example, we write VA equal to minus VB.
Boleh. If let's say you define your coordinate system S ini naik ke atas positif, then you will get VA is equal to minus VB. Sama sahaja. Tak ada masalah. Boleh.
Okay, thank you.
It's just negative sign di sini menunjukkan direction sahaja. Direction ini based on what? Based on kita punya coordinate system. So now we define coordinate system positif ke bawah. So that's why whatever is going up, dia akan jadi negatif. If you define coordinate system positif ke atas, whatever is going down will be negative. Okay? Alright. Itu for velocity. Then step number 8, if you want to find the acceleration, what we need to do is simple, differentiate lagi sekali, because we know that d over dt of v ataupun dv over dt is equal to a, acceleration. So once we have from previous vb is equal to minus va, then we differentiate these two components, we will get ab is equal to negative aa. Okay. Do you have any question? Okay. Kalau tak ada soalan, you have to remember that for this subtopic, dia tak ada specific formula. Formula ni bukan boleh guna untuk kesemua problem. It depends on the problem. So that's why one of the outcomes for today's lesson is for you to be able to formulate relationship between position dengan chord length, and then you need to derive sendiri the velocity and acceleration equation, because dia tak ada specific equation yang boleh pakai sama untuk semua keadaan, depending on the problem lah. So sometimes yang saya tunjuk tadi is a simple one, two objects, one pulley. That there are also problems yang ada dua objek but four pulleys, for example, ataupun three pulleys. When you face this kind of problem, you need to formulate the relationship first and then derive the velocity and acceleration punya equation. Okay, so to summarize this topic, there are certain procedures ataupun steps tadi yang you have to follow. So I made a summary here. These procedures can be used to relate dependent motion of particles moving along rectilinear path. Okay, remember, only for rectilinear. Rectilinear ni apa? Path dia straight line. Dia bukan curvilinear. And ini most important, only magnitude of velocity and acceleration change, not their line of direction. Maksudnya, velocity and acceleration dia boleh berubah, bertambah, berkurang, tapi dia mesti berada pada line direction yang sama. So kalau dia daripada bawah naik atas je. Dia tak boleh pergi kiri, dia tak boleh pergi kanan. If that's the case, then it's a different problem. We cannot use this procedure anymore. Okay. So again, the first step is to define. Yes. Okay. The first step is to define coordinate. Okay, tadi kita dah cari the origin, position coordinates, fixed datum line. We draw a datum along the path, and different datum lines can be used for each particle if the case is at an angle related to that. Relate the position coordinate to chord length. Ini yang kita buat tadi. Kita cari panjang keseluruhan tali tersebut, total length LT, and we make some relationship with SA, SB, and also the constant length. Okay, that is second step. Segment
Sir?
of, yes.
Yang ni tak guna gravity ke?
Tak ada.
Tak ada.
Belum. Kita belum belajar berkenaan force lagi. Force kita akan belajar pada chapter kedua. Okay, kita belum cerita lagi tentang force. Gravity tu dia masuk dalam force. Okay. Sekarang ni kita hanya belajar tentang position, velocity dan acceleration. Kita belum cerita lagi tentang force yang menyebabkan motion berlaku. Alright. Okay, so kat mana saya tadi? Relate the position to the total length. Okay, ni segment of chord that do not change. Maksudnya constant segment of the chords tu kita boleh left out. Maksudnya because bila kita differentiate the constant length, dia akan jadi equal to 0. So that's why dia kata boleh left out, boleh ignore, boleh buang sahaja. Okay, if a system contains more than one chord, relate the position of a point on one chord to a point on another chord. Separate equations are written for each chord. Okay, ini dalam case yang melibatkan banyak tali yang berbeza. Okay, and then differentiate the position to relate velocities and acceleration. Keep track of signs. Ini important. Keep track of signs ni maksud dia yang negatif dengan positif tadilah. Kalau you define coordinate ke bawah, maksudnya pointing ke bawah is positive, pointing up will be negative. If you define positif ke atas, bawah will be negative, point ke atas will be positive. So itu maksud dia keep track of signs. Okay. Do you have any question? If you don't have any question, then I would like to show a few examples on the calculation for this topic. Ada apa-apa soalan? Tak ada, eh? Okay. So kalau you tak ada soalan, let's look at this problem. Example problem 1. Okay. So ini dah tak sama dengan yang tadi. As you can see, there are one object and then there is one pulling force di point A. So point A is basically moving down with velocity of 3 meter per second. So dia bagi velocity A ke bawah. dan it is all of this is connected through a number of pulleys lah. Ada 2 puli kecil, ada 1 puli yang besar. Dan kita nak tahu what is the velocity of D if A is pulled down with a speed of 3 meter per second. Berapa velocity D naik ke atas? So that is the question. Okay. Let's try to solve this. Do you have any question before that? Ada soalan? Tak ada soalan? Boleh saya tunjuk macam mana kita nak selesaikan ni?
Yes.
Okay. Alright. Okay, so what is the first step tadi? Bila kita nak solve ini. What is the first step? Origin, okay. Origin dan juga datum. So let's say in this case we have 2. Saya zoom in sikit. We have 2 fixed point, okay, pada B dan C. So let's just pick one lah. Let's pick this point sebagai kita punya origin O. Okay, boleh nampak kat situ And then step number 2 is at the origin you define a datum. So you boleh garis datum pada origin tersebut. Okay. Okay, macam tu. So this will be the datum. Okay. Next step is apa? What is the next step? Sekarang kita dah ada origin, kita dah ada datum. Next step is to define kita punya coordinate system kita. Okay, so let's say I decide this coordinate system will be S ke bawah. Okay, kita define ke bawah sebagai positif, so this will be S. Okay, S kita ke bawah positif. Alright. So what is the next step? Next step is to identify the constant. Betul tak? Constant length. Okay, dekat mana yang constant length? Boleh siapa-siapa bagi tahu saya. Ada berapa tempat constant length dalam sistem ini?
2.
Ada 2. Dekat mana?
Above the table.
Okay, above. Okay, so di sini we have one constant length. Okay, dekat sini 1. Dekat C ni ada 1 constant length. Okay, the other one dekat mana?
Ini ada tulisan.
Okay, puli bawah. Puli bawah pun kita ada constant length di sini. Okay, ni pun ada tali di bawah ini yang constant. Okay. That part is settled. So we have identified the constant length. So saya tulis sikit. This is constant. Constant. This one is also constant. This constant as well. Okay. Next step is to do what? Next step is to find the position of kita punya object dalam ni with respect to our coordinate system tadi. So, how many objects do we have in here? How many objects yang kita ada dalam problem ini? 1 or 2? Berapa objek ada? 1 ke 2? 1, okay. Betul, we have only one object, but that point A which has the velocity VA is also can be considered as an object lah. Basically sebenarnya tadi we have mass A and mass B, tapi in this case something is pulling at A, that also can be considered as an object because we need to define the relationship for that part also, that chord also. So we have from datum, when we would like to identify ataupun define the position of the object, we start from datum. So from datum going to point A. Okay, so this will be one position. Let's call this SA. Okay, this is SA. Okay, so basically SA cover this rope lah, this part of the rope. Okay, remember kita punya aim is to cover all part of the rope. Barulah kita dapat buat relationship with the total length of the rope. Okay, sekarang ni length of rope yang tinggal ialah this part. So we can then draw another position until here. Okay, until here, this will be, let's call this SD, because the object here down here is D. Okay, SD ni dia refer to these three chords. This one SD, same length with this one. Okay, same length with this one, and also same length with this one. Okay, so basically SD ni ada 3. 1, 2, and 3. 3 parts of the chord can be represented by SD. Do you follow so far?
Yes.
Boleh? Okay. So the next step ialah to write the relationship to the total length. Okay. So relationship to LT, total length of the chord. Okay. So we have LT is equal to, kita kena tambah ke semua chord length ni lah. Okay, the first we have SA plus SD tadi ada 3 kan, 3 SD. So we write 3 times SD lah, 3 times SD. Okay, and then we need to add also the constant part. So constant ni, let's call this as C. Constant ni doesn't matter, walaupun dia ada 5 ke, ada 3 ke constant dalam problem ini, you need to write only C as the constant, because this constant dia tidak berubah. Dia nama pun constant, it will stay, the length will not change with time. So kita just write it as C. So this will be the relationship yang kita ada to represent the total length of the chord. Okay. Ada soalan tak tentang total length before we do the differentiation?
Tak ada, sir.
Tak ada Okay. So kalau tak ada, next step is macam biasa lah, we differentiate. So d over dt of LT, which will be equal to 0, sama dengan d over dt of SA plus d over dt of 3SD plus d over dt of C. Okay, of C. Okay, so this one will be 0, this one will be 0 also. Okay, kita tahu yang tu 0. So d over dt of S ataupun ds over dt will give us the velocity. So what we have here is VA plus 3VD is equal to 0. Okay, this is the relationship that we have. And then kita nak cari apa tadi? Kita nak cari VD kan? Kita nak cari VD. So VD will be minus VA over 3. Okay, that will be the relationship. So we know that VA is given here. VA is given 3 meter per second. So then what we do is just to substitute the value lah. Therefore, VD is minus 3 over 3. That is equal to VD is equal to minus 1 meter per second. Okay, that will be the answer, minus 1 meter per second. And based on the coordinate system yang kita define di sini, okay, we define here the coordinate system, we know that VD minus means that it is moving up. So kalau you nak tambah kepada jawapan you can also draw an arrow to show, to indicate that the apa ni, the thing is moving up lah. You just draw arrow pointing up, menunjukkan dia apa ni, the object D ni is moving up based on the coordinate system yang kita dah tetapkan. Okay, is this clear? Do you have any question? Jelas tak?
Clear, sir.
Clear? Okay. So kalau clear, let's look at the next example. Boleh nampak tak ni? Saya bawa sini sikit. Okay. Alright. Determine the velocity of block A if end B of the rope is pulled down with the speed of 6 meter per second. Okay, 6 meter per second. So ini dia punya gambar problem dia. Okay. Same like previously. What is the first step? What do we do first? Origin. Okay, origin and datum. So let's say kita pick this point as point O. Okay, then kita draw datum pada point O tersebut. So this will be our datum. Okay. Now, next is to do what? To identify the constant. Okay, dekat mana yang constant? Can you tell me which part is constant? Okay, let's take this part up here, constant, betul tak? This part saya zoom in, this part is constant. This part is also constant, betul? Okay, dekat puli mostly semua constant lah. And then we have this part is constant. Okay. Mana lagi constant? Puli bawah ni kan? This part is also constant. Dekat mana lagi? Tali ni macam mana? Do we need to pay attention to that rope? Perlu tak? Tak payah. Kenapa tak payah? Sebab dia tak terlibat pun dengan tali yang sedang ditarik ni. Dia kekal je pada length tersebut dan dia memang tak ada kaitan dengan tali yang selainnya. So tak perlu kita nak include tali tersebut. Okay, bahagian mana lagi yang constant? What about this one? Sini. Constant tak situ? Yang kecil tu. Constant kan? Okay, so di atas daripada datum ni pun constant di sini. Okay, so tinggal bahagian mana lagi? Ada lagi tak yang constant dalam ni? Ada lagi tak yang constant?
Tak ada.
Tak ada? Okay, saya nak tanya you. Tali ni dengan tali ni macam mana? Dia berubah tak? Dua tali yang tengah tu. Tak berubah kan? Okay, so bila dia tak berubah, you tarik, sepanjang you tarik 6 meter per second itu, tali ni, sebab dia dah satu connected pada puli di atas, satu connected pada puli di bawah. Puli, kedua-dua puli ni fix tau. So memang dua tali yang di tengah ni sebenarnya tidak berubah juga. So this is also constant. So this one is constant. Let's draw a red color for this constant part. Okay, so yang ni constant. Okay, so yang tinggal hanyalah tali yang 6 meter per second ini dan tali yang ini. Okay, so now kita akan define the position. This will be as B. Okay, position untuk point B, tangan yang nak tarik tu, 6 meter per second. Dua ini, okay, dua ini sepanjang apa nama dia, pergerakan ini dia sama tak? Kalau dia naik bersama tak? Kedua-dua tali ni sama kan? Sama. Okay, so which means that this will be as A. Dan bukan satu sahaja, dua yang akan jadi SA. This one and also this one. Kedua-duanya akan jadi SA. So sekarang ni we can then write the relationship of this. Okay, we have LT, total length, is equal to 2 SA plus SB plus the constant. That's the constant. So this will be the relationship. And then as usual, to find the velocity, kita differentiate. So bila kita differentiate, this one will be 0. This one will be 0. This one will be 2 VA plus VB is equal to 0. Okay, so sekarang ni kita nak tahu apa? Kita nak tahu VA. Therefore, VA is equal to minus VB over 2. Okay. VB kita tahu 6 meter per second. So, VA will be minus 6 over 2, which is equal to minus 3 meter per second. Dan kita tahu minus 3. Oh, kita lupa nak bagi tahu tadi kita punya axis kita define positif ke bawah. Kita punya axis S ni kita define positif ke bawah. So that's why we get negative answer, because VA is moving up. VA ni naik ke atas. So this will be our final answer, and you can also draw arrow lah untuk tunjukkan dia punya motion, which is ke atas. Okay. Ada apa-apa soalan? Is this clear?
Clear, sir.
Clear? Okay. Alright. Okay, let's look at one last example. Yang ni saya skip. Kita pergi ke yang ni terus. Okay, boleh nampak? Determine the velocity of car A. A ni ataupun the wagon ke apa yang bawa barang A ni, if point P, ada satu point P kecil di sini yang connected kepada motor. M di sini ialah motor. So if point P, dia tulis sini, if point P on the cable has a speed of 4 meter per second when the motor M winds the cable. Motor M tu pusing kabel, okay, menyebabkan P itu bergerak ke atas dengan 4 meter per second. Okay. So sekarang ni how do we solve this problem? Where do I define my coordinate, my origin? Dekat mana? Dekat mana nak define origin? Dekat mana origin?
Dekat motor.
Dekat kereta putih, dekat kereta A. Dekat motor sini. Here. Ke dekat sini?
Puli.
Dekat
Puli yang dekat dengan motor. Puli yang dekat dengan motor tu.
Yes. So origin kita define di puli, bukan di motor. So ini kita punya origin. And then kita akan draw kita punya datum lah, reference line kita passing through the origin. Okay. So ini kita define sebagai datum. Okay. Koordinat kita nak define ke mana? Pergerakan ni ke mana? Atas ke, bawah ke, sengit ke? Macam mana kita nak define kita punya coordinate system? Koordinat kita hanya ada satu sahaja. Remember, for absolute, for dependent motion ni ada satu je. So kita nak define koordinat kita ke mana? Sengit ke bawah kan? Betul tak? So saya akan define koordinat saya ke sini sebagai positif. Betul tak? Ini akan jadi kita punya S. Koordinat kita. Betul? Boleh? Boleh nampak? Okay. So sekarang ni saya zoom in kan untuk kita cari bahagian mana yang constant. Yang penting tu bahagian mana constant dulu. Lepas tu barulah kita akan tengok dia punya relationship. Okay. So di atas ini, di puli memang akan constant lah. So di puli ni satu constant. Motor, sini ke motor mestilah constant. Betul tak? So itu part yang constant juga. And then we have this part here constant, and then this part here also constant. Alright. Oh, actually yang bawah ni dia constant sampai ke sini boleh. Betul tak? Sebab ini fix tau, dia tak akan berubah sampai ke sini. Kalau saya boleh buat satu garisan di sini macam macam tu. So you nampak tak? Dia tak akan berubah panjang tu because of that pulley connection yang ada dekat sini. Boleh nampak ke? Boleh tak? Boleh nampak tak? Nampak Okay. So ini yang mana constant. Maksud yang kita dah warnakan dengan merah ni yang constant. So yang tinggal ni, ini je panjang tali, length of tali yang akan berubah mengikut masa, with respect to time, dia akan berubah. Okay. So yang pertama, kita boleh define kita punya sehingga ke sini lah. So I will take this sampai ke sini. This will be apa? Apa nama tadi? A. So yang ni kita panggil sebagai SA lah. SA. Ada berapa SA semua sekali ni? Ada berapa panjang SA? 4. Betul. Ada 4 panjang SA. Tapi kita juga kena apa nama dia ya? Kita kena consider juga point P, sebab P yang ada velocity. So okay, betul, kita ada 4 SA. Okay, saya gariskan ini, sini 1, sini 2, yang ini 3 dan yang bawah ini 4. So semua sekali ada 4 SA. Tapi kita kena juga includekan point P. So daripada sini sehingga sini, sehingga ke point P, this will be SP. Okay. SP. Okay. So sekarang, macam mana kita nak tulis relationship untuk LT, total length? LT sama dengan
3 SA
3 SA, okay. 3 SA plus
SP tolak SA. SA tolak SP.
SA tolak
SP.
SP. Macam ni 3SA. Okay, ni 3SA akan cover yang ini, yang pertama. 1, 2, 3. Yang ini ialah the whole thing is SA. Lepas tu yang ini ialah SA tolak SP. Betul lah? Okay, and then plus C lah, plus the constant. Alright. So, bila kita differentiate untuk cari velocity, kita tahu yang ini akan jadi 0, the constant. Yang constant C pun akan jadi 0. Okay. Dan di sini kita ada 3SA plus SA akan jadi 4SA. So, kita akan dapat bila differentiate over time, ds over dt tadi. Okay, ds over dt kita akan dapat 4 VA minus VP sama dengan kosong. Okay, 4 VA minus VP sama dengan kosong. Okay, so kita nak tahu apa? Kita nak tahu VA. So, VA is then equal to VP over 4. Okay, VP diberi di sini 4 meter per second. Therefore, VA is then 4 per 4, which is VA is equal to 1 meter per second. Arah dia ke mana ni? Arah dia ke mana? Salah ni. We should key in VP ni negatif 4. VP ni sepatutnya negatif 4. Kenapa? Kenapa VP negatif 4? Ada siapa boleh bagi tahu saya tak? Kenapa VP kita kena tulis sebagai negatif 4?
Dia bertentangan dengan S.
Correct. Dia bertentangan dengan kita punya coordinate system. Coordinate system kita S ke bawah, saya ingat ke bawah, tapi VP ni ke atas. So saya akan lukis sikit VP ni ke sini. This is VP yang diberi sebab point P is moving up. So VP ke atas, which means that dia ialah negatif 4. So our final answer should be negative 1 meter per second. Barulah dia make sense because VA is also going up. Okay, bila tali tu tarik, the car A tu tadi akan bergerak ke atas ke arah yang bertentangan dengan coordinate system kita yang kita dah define di sini, S ke bawah. So that's why it becomes negative. Okay, so this will be the final answer lah, negative 1 meter per second. Okay, do you have any question? Ada apa-apa soalan? No question?
No question.
Okay. So, if there is no question, that is all for today. It's just a simple subtopic. Tapi you need to be careful lah untuk cari dia punya total length dan juga formulation macam mana untuk dapatkan velocity tadi. So, in summary, what we have learned today is how to formulate a relationship between position and chord length. Chord length ni LT tadilah, total length of the rope. Use the formulation yang kita ada tadi, LT sama dengan SA plus SB constant dan sebagainya tadi, to derive the equation of velocity and acceleration. Kita tadi buat a few examples to calculate the velocity. Kita belum buat yang acceleration. Maybe later I will give you a few tutorial and then how to solve it lah for the case of acceleration. and also we did solve 3 problems related to dependent motion of 2 particles. So itu yang kita telah berjaya buat untuk hari ini, and that is the second last subtopic lah untuk kita punya dynamics chapter 1. Okay, dynamics chapter 1. So basically now what we have left is only to cover the relative motion lah, which is the last subtopic, relative motion. Yang ni kita akan cover pada Monday, hari Isnin nanti insyaAllah. Okay, so is there any question that you would like to ask before we end the class for today? Ada apa-apa soalan?
No.
No question. I hope everything is clear. And as usual, I am recording this session. I will upload in YouTube as well as in Google Classroom, and also the slides, the tutorial questions and answer tadi pun I will upload also in YouTube lah, for your reference. In Google Classroom, in Google Classroom for your reference. So if there's nothing more, no question, thank you again for coming to the class, and I will see you again next Monday same time, 2 p.m. Okay.